The universe is so vast. Can we go visit some planets outside of our solar system? If we could travel at the speed of light, maybe you could just look up and see the teardrop planet outside the window. But with current human technology, we can't even achieve 1/1000th of the speed of light. And those planets outside of our solar system are over 10,000 kilometers away. According to our current technology, how many years would it take for us to get there? How are we going to reach those distant planets in the galaxy? What are the advancements in human space exploration technology? Any exciting developments? Let's dive into today's topic. Maybe this will give you a glimmer of hope for interstellar travel. From our perspective as humans, the closest star system to Earth is the triple star system of Alpha Centauri in the constellation Centaurus. The smallest star in this system is called Proxima Centauri. Currently, 2 planets have been confirmed. There's this little planet spinning around a red dwarf star. One of them is a planet called Proxima Centauri b. It's right in the habitable zone. If we want to go check out Proxima Centauri b, the biggest obstacle is the technological limitations. Even though Proxima Centauri is only 4.2 light years away from Earth. A light year is the distance light travels in a year. Light travels at a speed of about 186,000 miles per second. So basically, if we were to travel in a spaceship at the speed of light, it would take 4.2 years to get there. If we convert that to miles, it's roughly 40 trillion miles away. But right now, we don't even have the technology to make humans fly that fast. So in terms of speed, how far do humans want to go for interstellar travel? Currently, we have 2 probes for reference. One is Voyager 1, launched in 1977. The other is the Parker Solar Probe for exploring the Sun. Voyager 1 travels at about 17 kilometers per second. That's speed. It would take roughly 17,500 years to travel 1 light year. It would take at least 73,000 years to reach Proxima Centauri. This speed for interstellar travel is just way too slow, and human lifespan is so limited. Therefore, this is a task that is almost impossible to accomplish. Another one is so far. The Parker Solar Probe, the fastest spacecraft in flight speed. It's heading straight towards the Sun. It happened on December 24th, 2024, setting a new record of 192 kilometers per second. At this speed, it would take about 6,590 years to reach Proxima Centauri. Compared to Voyager 1, the Parker probe's speed has seen a significant boost, but when it comes to exploring the universe, still seemed so insignificant. Heading to distant planets at this speed, still far from enough. We should figure out a way to increase our flying speed, or prolong human life, only that it might be possible. So, any new propulsion technologies? Controlled fusion technology might offer hope. Controlled fusion technology is a highly promising future energy solution. So, here's the idea. We take hydrogen nuclei, and under crazy high temperatures and pressure, we fuse them into heavier nuclei. Boom! Massive energy released. Boom! We've got ourselves a kick-ass power source for interstellar spacecrafts. Right now, the Princeton Plasma Physics Lab is deep into developing the technology. The crew there is itching to launch it into space for testing. They even want to use it for the main thruster of spacecraft within the solar system. And the British startup company, Post Fusion, is developing a project called Summer, a nuclear fusion-powered rocket, scheduled for an orbital demonstration in 2027. By then, the specific impulse of the fusion rocket can reach very high levels. Some studies suggest, theoretically, with the fusion rocket, they can accelerate the probe to 12% of the speed of light. That is approximately 36,000 kilometers per second. This speed is about 188 times faster than the Parker Solar Probe. If a fusion rocket can accelerate a probe to 12% the speed of light, then the travel time to Proxima Centauri would be shortened to about 35 years. A round trip would take only 70 years. For us, this would be a feasible space exploration mission. We're going to Mars at this speed. Jupiter and Saturn will be a piece of cake. But with fusion drive technology, we still have a long way to go before reaching light speed. According to Einstein's theory of relativity, no object can ever reach the speed of light. We can only get infinitely close to it. So, besides the distance separating us within the solar system, technology is also a major challenge. If we really find a way to travel at the speed of light, then if we go to the sun, it would only take 8.3 minutes to get there. Taking the subway to Proxima Centauri would only take 4.2 years. But if we want to go near the center of the Milky Way, it might take 26,000 years. If we want to go to the closest galaxy, to the Milky Way, the Andromeda Galaxy, it would take 2.5 million years. So you see, the universe is beyond gigantic, mind-blowing. Even if we could build a spaceship that travels at the speed of light, the places we want to go are still very far away. The destinations we want to reach are still very limited. So, theoretically speaking, is there a way to travel even faster? Like warp engine technology and impulse power. I believe many people have heard of them in science fiction novels. It's like warp drive technology. With it, we can control time and space itself, exploiting loopholes in physics to achieve faster-than-light travel. The closest thing to this concept is the Alcubierre warp drive. It was proposed by Mexican physicist Miguel Alcubierre. He believed that by bending space-time, we might solve the problem of faster-than-light travel. His theoretical approach was, as the spaceship heads toward its destination, the space in front of it will contract, while the space behind it expands. The spaceship and its crew are inside a warp drive, cruising through flat space. Even though it sounds like science fiction, some physicists believe that it might be achievable in the future. And then there's also wormholes. Wormholes are only predicted by Einstein's general theory of relativity. We've mathematically predicted his existence before. But so far, wormholes are still just a theoretical concept. No one has actually seen one before. Let's imagine for a moment, if we could punch a hole in the fabric of the universe, and then somehow bend it in a way to jump straight from one place to another. How mind-blowing would that be? If it were actually possible, maybe we just don't need those after all. Spaceships that fly faster than light just go straight through a wormhole. But objects like the Sun and Earth can already warp space-time. It's just about keeping that wormhole open. You need negative energy or negative mass. It's like anti-gravity. Let me give you an example. If Earth had negative mass, that ball standing on Earth will accelerate up to the sky when released. But here's the thing. The wormhole theory faces the challenge of needing more negative energy than allowed by the laws of physics. For example, to open a grapefruit-sized wormhole would require the sun to generate energy for over 1 billion years. That's not very likely to happen, unless we reach the most advanced miracle civilization in the universe. Maybe we can pull it off. For now, warp engine technology and wormholes are just too sci-fi. Developing controlled fusion technology, it might give us a glimpse of hope for interstellar travel. Even if we can only reach 12% of the speed of light, there's still a chance to travel to some stars near the solar system and explore what's out there in the system. Like heading to Proxima Centauri, Barnard Star, maybe even take a trip near Sirius. But here's the catch. We gotta seriously boost the ship's speed. That way, humanity can uncover even more cosmic secrets.